This video will focus on problems where you have variables on both sides. We're working on multi-step equations now. Example 1. What you'll notice that's special about this problem is that we have variables on both sides. The left side of the equal sign I'm going to label with an L. The right side of the equal sign I'm going to label with an R. And then what we're going to do is we're going to move all of the variables to one side and all of the constants to the other. What I'm going to do is I'm going to write a V when I want to represent variables with their coefficients. And I'm going to write a C when I want to represent the constants. The first thing I like to move, and you don't have to move this first, but I like to move the variables with their coefficients. You could start with the constants if you wanted to. Again, as long as you do the same thing to both sides, it's a legal move. So we're going to just do it how I normally do it, and I'm going to move the variable that has the smaller coefficient. A coefficient of negative 11 is smaller than a coefficient of negative 3, so I'm going to move the negative 11x using inverse operations. Negative 3x plus 11x gives me 8x. You'll notice that I didn't put the 11x under the negative 32 because those are not like terms. Negative 3x and 11x are like terms. And in fact, when I look at the left side, 8x minus 32, I still cannot simplify this any further because those are not like terms. Like terms have the same variables with the same coefficient, with the same exponents. On the right side, negative 11x plus 11x is a zero pair, so I'm left with the 64. So you'll notice that I moved the variables to the left side. Since I moved the variables to the left side, I labeled it with a V. So I was actually thinking ahead. The V is on the left side. The C is on the right side because it represents where my constants need to be. This constant does not belong on the variables with their coefficients side. It needs to be moved to the right side. So I add 32 to both sides to remove the negative 32 from the left side. On the right side, I'm left with 96. Now, the final step here is you look at 8 and you see how 8 is separated from the 96, or from the x, and it's separated by multiplication. The inverse of that is division. 8 divided by 8 gives you 1x, and on the right side, we have to do the same thing to maintain equality, and we get 12. So x equals 12 is your solution to number 1. Move on to number 2. In number 2, what I'm going to do is I am going to this time, instead of moving the smaller coefficient, which would be the 3x, the 3x has a coefficient of 3, I'm going to move the larger coefficient, the 4, and the x. So the coefficient of 4 with the x is what I'm going to move. Since the variables will end up on the left side, I'm going to label this V. On the right side, I'm going to label it C because the constant should be on the right side. 3x minus 4x gives me negative 1x. I carry down the negative 20, the equal sign, and then I have a 0 pair on the right side, so I'm just left with 5. Now you'll notice that I was left with a negative 1x. When you move the variable with the larger coefficient, what's going to happen is you're going to end up with a negative value. You could end up with a negative value for the coefficient. Usually that's what happens. So the reason why I don't like to do that is because I find that I and students and people in general make more mistakes when they have to keep carrying a negative down or divide by a negative or multiply by a negative. So I like to avoid the negatives when possible to reduce my possibility for error. On the left side, we needed to move that negative 20 to the right side so that all the constants are on the right side. So I added 20 to both sides. On the left side, I'm left with negative 1x. On the right side, we get 25. Then we think about how negative 1 and x are separated. They're separated by multiplication. So we use the inverse operation division to get rid of that -1. -1 divided by -1 is just a +1, and so it's +1x, and then on the right side we get -25. So x equals -25. That's your solution to number 2. Number 3, we have a 4x and a 10x, and I'm going to move the 4x because it is the variable that has the smaller coefficient. I realize that I'm moving the variables to the right side, so I'm going to put the constants, the C label, on the left side. On the left side, I'm left with the constant -85. On the right side, I'm left with a constant 23 and a +6x when I combine these two that are like terms. Then I need to move the constant term, 23, to the left side by using inverse operations. On the left side, I get -108, and on the right side, I get 6x. The 6 and the x are separated by multiplication, so we use the inverse operation division, and we divide both sides by a +6. On the left side, I get a -18. On the right side, I'm left with 1x, so x equals -18 is the solution to number 3. In number 4, instead of moving the variables first, I'm going to mix it up, and I'm going to move the constants first. So I'm going to move the constant -18, and since I move the constants to the right side, I put a C above the right side, I put a V above the left side. On the left side, I'm left with -5x because 18 minus 18 is 0, it's a 0 pair. And then on the right side, I get -3x, I just carry that part down, and then I add 8 and 18. And then now I'm ready to move the variables. So I'm going to add 3x to both sides. On the left side, I'm left with a -2x. On the right side, I'm left with a +26. And then I divide both sides by -2, and we get x equals -13. So the solution number 4 is -13. And our final problem that we're going to work on together is number 5. I'm going to move the -7x because -7 is a smaller coefficient than -6. So I add 7x to both sides. On the left side, I'm left with x minus 9. On the right side, I'm left with 13. And I know that I move the variables to the left side, so I label the right side with a C for constants. The constant -9 does not belong on the variable side, so it needs to be moved to the right side. So I add 9 to both sides. I use my inverse operations to get rid of that -9. On the other side, I get, x equals 22. So the solution to number 5 is x equals 22. Now I want you to complete 6 through 10 on your own for practice.